everyone. In this video, we will be studying about combination of cells. Okay. We'll be studying three cases. The first one is series, then parallel, and then mixed grouping. Right. So the first case means the first part is series combination of cells. Right. So we are taking example. Okay. Three cells are connected. Right. And external resistance. These cells are having EMF E1, E2, E3. Okay. Internal resistance R1, R2, and R3. Suppose current I is flowing through them. Okay. Now, applying KVL, okay, in this part, in this circuit, okay. On applying KVL, it will be I into R3. We are moving from here to here, and then we'll come here, okay. There from on passing R3, there will be a potential drop, and we are taking potential drop as positive. I into R3 plus, sorry, it will be minus R3 minus E3, okay, plus I into R2. Why minus E3? Because there is a potential rise, okay. I'm again telling you that you can take potential drop as negative and potential rise as positive. It all depends on you. But in generally in this chapter, I am taking potential drop as positive and potential rise as negative. Okay. Okay. So ये हो जाएगा minus R2 minus E2 plus I R1 minus E1 plus I into R is equal to 0. From here you will get I is equals to E1 plus E2 plus E3 upon R1 plus R2 plus R3 plus R. Okay. So yeah, this is your I, and your E equivalent, EMF equivalent, it will be E1 plus E2 plus E3, okay, and so on. And your R equivalent, it will be R1 plus R2 plus R3 and so on. Okay. Now, if n such cells are connected, right, what will be I will be E1 plus E2 plus and so on up to En, okay, upon R1 plus R2 plus R3 and so on up to Rn plus R. Okay, right, this was your case. That means from here you can write it as E equivalent upon R equivalent plus R. Okay, and if all the n cells are identical, then E1 plus E2 plus and so on up to En, it will be n into E. Let's say their EMF is E upon n into R plus if all cells are identical, right? This was your first case. Okay, if special cases will take if cells are new, okay, then what will happen? NR will be very much less than external resistance, obviously. Okay, that means you can write NR plus R approximately as R. From here you will get I is equals to N into E upon R, right? That means I is equals to N into current given by the one cell. Okay, for used cell, you can write for used cell what will be, it will be R, small r will be very much greater than R because they are used. Okay, so their internal resistance will become very high, right? And cells are new, their internal resistance is actually quite low. Okay, so it will be NR plus capital R is approximately N into R. So I will be E upon R approximately N into, sorry, will be I is equals to E upon R. Okay, this is what current given by the one side, right? Thus, when internal resistance are large, there is no advantage of connecting such cells in series because the current is actually we are getting E by R, right? Now, the second case is parallel combination of cells. Okay, parallel combination we are taking two cases. Okay? We are taking two cells. They are connected in parallel. Okay, then external resistance, the capital R, E2, R2. Suppose a current I is initiating from here I1, let's say here from I2, and they are coming here I is equals to I1 plus I2, and they are passing through it. Okay. Let's say this point is actually A, this point is B, this point is C, this point is. Now, you know that R equivalent it will be 1 by R1 plus 1 by R2 for this circuit. Okay, for this. Okay, and and uh, now we are going to apply KVL in this loop. Okay, in which loop? In this loop A, B, C, D, E1, right? Applying KVL in A, B, C, D, E1, A. Okay, let me draw it by in this loop. Okay, right? So on applying KVL, what will be equation? It will be I1 I1 minus E1 plus I into R. We are taking I as I1 plus I2. So from here you will get I1 is equals to E1 minus I into R upon small r1, right? Now applying KVL in A, B, C, D, E2 and A in this loop. Okay. I hope you understood this in this loop. Okay. So on applying KVL in this loop, you will get I2 as E2 minus I into R upon R2, because the equation will be somewhat like this: I2 R2 minus E2 plus I into R, okay, equals to 0, right? Now you know I is equals to I1 plus I2. So I is equals to E1 minus I into R upon R1 plus E2 minus I into R upon R2, right? So it will be I into 1 plus R upon R1 plus R upon R2. We are taking to this side it too. Okay, E1 by R1 plus E2 by R2, right? From here you will get I is equals to E1 by R1 plus E2 by R2 upon 1 plus R1 by R1 plus 1 by R2, right? So this is what? This is actually your, you can write it as I is equals to, it will be something like this: E equivalent on comparing with, sorry, you can write it as that form which we have written, that R equivalent 1 by R1 plus 2 by R2 upon R equivalent plus R. Okay. upper part, that R equivalent into E1 by R1 plus E2 by R2, that is your E equivalent. This is your E equivalent, and this is your R equivalent. Okay. Now for n cell you can also derive E1 by R1 plus E2 by R2 and so on up to n. Okay, and again for you will take two special cases, if cells are new and if cells are old. Okay, you can do that for this type. Okay. Uh, in the next video we'll study about mixed grouping and we'll also solve one problem. Okay.